Decollage liftoff from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe.
The James Webb Space Telescope has just brought us beautiful pictures, and many of us were wonderstruck. But some of its most amazing observations won't come from just beautiful pictures. Recently, Webb captured the most astonishing detailed spectrum of an exoplanet's atmosphere ever. You've probably heard about WASP 96 by now. These results have been reported in a large fraction of the world's media outlets. This is the first time the spectrum of an exoplanet has lit up New York's Times Square. Welcome to Space Nomad, and today let's take a closer look and know what the observatory revealed about this exoplanet. WASP 96b. But before that, here's a quick recap of what we already know about WASP 96b. WASP 96b is one of the Milky Way's more than 5,000 confirmed exoplanets. It's around 1,150 light-years away in the southern sky constellation Phoenix, and it represents a form of a gas giant that doesn't exist in our solar system. WASP 96b is far puffier than any planet orbiting our Sun, with a mass less than half that of Jupiter and a diameter 1.2 times larger. And it is substantially hotter as the temperature exceeds 1,000 degrees Fahrenheit. WASP 96b orbits its Sun-like star at a fraction of the distance between Mercury and the Sun, completing one orbit every 3.5 Earth days. Due to its massive size, short orbital period, puffy atmosphere, and lack of contaminating light from surrounding objects in the sky, WASP 96b is a great target for atmospheric investigations. All the observations brought to us were possible with a method called transit spectroscopy. Let's quickly understand what spectroscopy is. The most successful method for measuring the chemical composition of an exoplanetary atmosphere is the transit spectroscopy method. The chemical composition of exoplanetary atmospheres can reveal a lot about these worlds' physical and potentially life-bearing circumstances. When an exoplanet passes in front of its host star, a small portion of the stellar light goes through the exoplanetary atmosphere, then into space, and finally into spectrographs onboard Webb, distributing the light into a rainbow of colors using high-tech prisms. As the light passes through the atmosphere, molecules absorb some wavelengths while allowing others to flow through undisturbed. Dr. Nestor Espinosa, an exoplanet researcher at Space Telescope Science Institute, which runs the James Webb Space Telescope, put it in good terms, saying each molecule has a specific diet. Just as an individual's fingerprints are unique, atoms and molecules have a unique spectral characteristic that can be used to detect their presence in celestial objects, and thus the chemical composition of the atmosphere can be deduced by measuring the fraction of stellar light received by the spectrograph. The spectrum of light recently captured by Webb shows that the WASP 96b blocked light waves from water molecules, meaning that there are water molecules present in its thick, fluffy clouds. So does that mean that life could exist on this exoplanet? Water is considered a key signature of life beyond Earth, after all. As explained by Avi Loeb, such planets are not thought to host life because they do not possess a thin atmosphere on top of a rocky surface, as Earth does. The combination of liquid water and a solid surface is thought to be crucial ingredients in the recipe for life as we know it. It is not the first time that water molecules have been found on WASP 96. However, James Webb's capabilities allow scientists to see these faraway worlds in unprecedented detail. Hubble identified water on this exoplanet in 2013, but a more comprehensive observation of JWST, on the other hand, represents a huge step forward in the search for characteristics of possibly habitable worlds outside the solar system. Its advanced design yields a dramatic improvement in spectral resolution and sensitivity. Webb's near-infrared imager and slitless spectrograph monitored light from the WASP 96 system for 6.4 hours on June 21st as the planet passed across its star. This produced a light curve depicting the overall lowering of starlight throughout the transit. as well as a transmission spectrum displaying the brightness shift of various wavelengths of infrared radiation ranging from 0.6 to 2.8 microns. The light curve confirmed the existence, size, and orbit of the planet, which had already been determined by previous observations. This portion of the spectrum is particularly sensitive to water, as well as other key molecules such as oxygen, methane, and carbon dioxide. Researchers will be able to utilize the spectrum to estimate the temperature of the atmosphere with depth, measure the amount of water vapor in the atmosphere, constrain the abundance of specific elements such as carbon and oxygen, and measure the amount of water vapor in the atmosphere. They can then utilize this knowledge to draw conclusions about the planet's overall composition, as well as how, when, and where it originated. The blue line on the graph is a best fit model that takes into consideration the data, known features of WASP-96b and its star, such as size, mass, and temperature, as well as assumed atmospheric properties. The extremely precise spectrum, created by examining 280 individual spectra taken during the observation, is only a glimpse of what Webb has in store for exoplanet research. Planetary scientists are delighted with the data obtained, and over the coming year, we will employ spectroscopy to examine the surfaces and atmospheres of several dozen exoplanets, ranging from small rocky planets to gas and ice-rich giants. Right now, we have more questions than answers about exoplanets, and we think the atmosphere might well be a window to understanding them better. It is exciting because with James Webb, we'll begin to know much more about what all that diversity really means. Till now, we have only been able to scratch the surface, and there is nothing more true than that. The capabilities of the telescope already indicate that there will be more astonishing discoveries about other distant worlds soon. So, are we just about to discover alien life in the near future? Or are we going to find ourselves a new home planet? Let us know your thoughts on it in the comments section below. Also, tell us which other exoplanets you want to see Webb research. Thanks for watching Space Nomad. For more such videos, do subscribe to our channel if you haven't already. Hit the bell icon to get notified whenever we upload a video.